Alright guys, welcome to lesson 10.5. Today we're going to learn about two special right triangles. One's called a 45-45-90 and the other one's called a 30-60-90, and these are their angle measures of each one of these types. And they have some interesting properties to them that will help us find missing sides. So let's go ahead and jump into this. Now, in our last lesson we talked about Pythagorean's theorem, and Pythagorean's theorem works for any triangle. But it requires two sides. In other words, it's only good for finding a missing third side. So the strength of the Pythagorean theorem is that it works for any triangle. The weakness is that you have to have at least two sides to completely solve the triangle. Okay. Now, special right triangles are a little bit different. They don't work for any triangle. They only work for special right triangles. The 30-60-90 and the 45-45-90. So it only works on those special types. But the cool thing is it only requires one side. So in other words, if I give you one of these special right triangles, you don't need to have two sides to find the third side. Matter of fact, you only need one side, and with that one side you can find the other two sides. So it can do a little bit more in that respect. And in some cases, it can actually even be a little bit faster, but that's not always the case, so I won't write that one down. But we do have two different ways to find missing sides of a right triangle. Now, we have Pythagorean's theorem, and we have special right triangles. Pythagorean's theorem works on any triangle, but it requires two sides in order to find a third side. Special right triangles only works for special right triangles, but when you have those, it's kind of cool because you only need one side to find the rest. So we're going to talk about some special right triangles today. Why do we care about these special right triangles? What makes them so special? Why do we have 45-45-90 right triangles? What about other kinds of right triangles, like a 50-40-90 right triangle would be another possibility, but that's not special. So what's special about these ones? Well, they work out really nice, first of all, so you end up with some pretty solid numbers. And that's mainly the reason. But what we're going to be using it for is because it actually is how we find the coordinates on our unit circle, which is a tool that we're going to be using, like I said, throughout this rest of our year with working with trig. So special right triangles are the way that we find the coordinates on a unit circle. What do I mean by coordinates? Well, so far we've found angles, right? And we've represented those angles with degrees. And we've also represented them with radians. But technically that is a point on a graph as well right there, right? And a point has an x value and a y value. Well, special right triangles can help us find out what that point is. Okay? And on our next lesson, not today, but in our next lesson, we'll see how that is. But for today, we're just going to learn about what these special right triangles are and how to work with them. So let's go ahead and get started with that. Here's some steps for the problems we're going to do today. The first thing we want to do is decide what kind of right triangle we're working with. What side did they give us? There's three sides, and each one of them has a role to play in this process. So you have to pay attention to what kind of triangle you have, what side is given, and from there we can apply the rules to find the missing sides. So that's the idea there, so I thought I'd include these steps as a nice reference point. So let's go ahead and begin with the 45-45-90 right triangle. So a 45-45-90 right triangle is called that because you have two 45-degree angles and a 90-degree angle. Okay. Now, when you have that, the legs on this triangle are the same. Okay, So if this leg is x, then this leg will have to be x. There's an old rule in geometry that says if you have two equal angles, which we do, then you also have to have two equal sides. All right? And so that's why we know that. Well, since both of these are x, you can use the Pythagorean theorem to find out what this third side would come out to be. Now, I'm not going to go through the process of showing that, but you can do the Pythagorean theorem with these two and find out that the third side here comes out being x times radical 2, or square root of 2. Okay? And so this is the 45, 45, 90 right triangle. All right? So now I'm going to add some notes on here, and I'm going to be referencing these notes as we go. But what we do know is that on a 45, 45, 90 right triangle, these two sides are the same. And I would encourage you guys to write this down. Okay? Now, what about from here to here? How do these two things relate to each other? Well, I can get from here to here if I just put a square root of 2 next to the x, right? So if I take whatever's here and I put a square root of 2 next to it, I get this, right? When you put it next to it, what you're doing is you're multiplying it. So if I know my leg, I can jump from here to the hypotenuse just by multiplying it by a square root of 2. And not surprisingly, then, if you were to work backwards, what would you do? Instead of multiplying by the square root of 2, you would divide by the square root of 2. So if I had my hypotenuse and I wanted to find out what this leg was, all I would have to do is divide by the square root of 2. So let's go ahead and take a look at an example like that. So step 1 is to notice that we are looking at a 45, 45, 90 right triangle. Now you might think, well, Mr. Bailey, there's only one 45 there. Well, just so you guys know from geometry, the angles of a triangle have to add up to 180. So if this is 90 and this is 45, this has to be 45 also, because that's the only way the angles would add up to make 180. So really they only need to tell you that one of the angles is 45, and that's good enough. Okay. Now, let's take a look at the rest of the triangle. So step 1 is to identify what kind of triangle is it. It is a 45, 45, 90 right triangle. Okay. Step 2 is to identify what side did they give me. Well, they gave me a leg. And here's what we know about the legs of a right triangle. We know that the legs are the same. So therefore, B must equal 3. Now, how do I know what the hypotenuse is? Well, we know that if I have the leg, I can get to the hypotenuse if I just multiply it by the square root of 2. So if I take 3 and multiply it by the square root of 2, I end up with 3 square root of 2. So A is 3 times the square root of 2, and B is 3. All right? Let's go ahead and have you guys try one of these. I'm going to skip around a little bit till I find one that matches well. I'm going to ask you guys to do number 5 here. So go ahead and pause the video here and see what you guys get. When you unpause it, you'll see the solution. All right, there you go. Since they gave me a leg, these two have to be the same. And then to get your hypotenuse, you should put a radical 2 next to it. So as you guys can see, since this is a 45, 45, 90 right triangle, it's a special kind of triangle, and it only works for this kind of triangle, but it's much faster than the Pythagorean Theorem. And we started with only one side instead of 2. All right, so there is some benefit to that. Let's go ahead and jump back here. I'm going to go to number 2 here. So write down number 2. This is another one that I'm going to do, and I'll find one for you guys to practice it. So what kind of a triangle am I looking at here? Well, no surprises. It's still a 45, 45, 90 right triangle. But the second step is to decide what side they've given me. Well, in this case, they've given me the hypotenuse. Okay. Now, how do you get from a hypotenuse to the leg? Well, that's kind of like working backwards. Last time we had the leg and we found the hypotenuse. We did that by multiplying by the square root of 2. But this time we're going from the hypotenuse to the leg. So this time what we're going to do is we're going to divide by the square root of 2 to get to the leg. So if I take my hypotenuse and I divide it by the square root of 2, the square root of 2 just goes away and I'm left with 7. Okay, so that means that b equals 7 and a equals 7. All right, so I'm going to let you guys try one of those. Clear that off and find one that fits here for you. Why don't you guys go ahead and give that one a try, and when you unpause the video, you'll see the solution. All right, so there you go. X and y are both 4. The hypotenuse is 4 radical 2, so if you divide by radical 2, the radical 2 goes away, and that gives us the legs, which are 4 and 4. All right, let's backtrack now. Let's take a look at number 3. All right, so once again, what kind of a triangle is this? It's a 45, 45, 90. Now you might think, Mr. Baylor, why do you keep doing that first step? It's silly. Well, because there's going to be a different one that we talk about later today. So I want you to always remember, ask yourself what kind of triangle you're looking at, because that's going to determine what rules you use. So for now, though, we're sticking with the same rules. So it's a 45, 45, 90 right triangle. What side did they give me? Well, they gave me a hypotenuse. How do you get from a hypotenuse to a leg? Well, in the last problem, we saw that you divide by the square root of 2. But that's interesting because on this one, if I take my hypotenuse and I divide by square root of 2, it's not like the square root of 2 just cancels out because there's not a square root of 2 on the top. When that happens, what we're going to do is we're going to rationalize this. You may recall from previous lessons that we don't like having square roots on the bottom. So what we're going to do is we're going to multiply the top and the bottom by the square root of 2. And that's going to give me my final answer there, which is 7 radical 2. And on the bottom, when you multiply these together, you just get 2. When you multiply 2 square roots together, the square root goes away and you're just left with that number. So I end up, by dividing 7 by the square root of 2, I get 7 over the square root of 2, which if I rationalize that gives me 7 radical 2 over 2. And that's what's going to go here. And since the legs are the same, it'll also go here. Okay, so let's go ahead and let you guys try one kind of like that. There it is. So go ahead and pause the video here. Give it a try. When you unpause it, you will see the solution. All right, so here are the answers. So you guys should have taken the 6 and divided it by square root of 2 and then rationalized and gotten this. But you may have noticed that these reduce. 6 over 2 is 3. So your most simplified answer would be 3 radical 2. All right, let's jump back and take a look at one more type before we move on to our next type of triangle here. Go ahead and write down number 4. Let's take a look. So once again, what kind of a triangle is this? It's a 45, 45, 90. And we know that on a 45, 45, 90, the legs are the same. So that means this V will have to match this one. They are both 7 radical 6 over 6. Okay. Now, how do you get from a leg to a hypotenuse? Well, we said before that you get there by multiplying the leg by the square root of 2. So I've got 7 radical 6 over 6. That's not a 6. And then we multiply that by the square root of 2. So how do we do that? Well, think of that square root of 2 as over 1. And let's just multiply straight across. I end up with 7 radical 12 over 6. Now, we're not done. You may have to simplify these things, right? So the square root of 12, let's do that first. The square root of 12 is the square root of 2 times 2 times 3, if you break it down. And if you take out your pair, you end up with 2 radical 3. So this is 7 times, instead of square root of 12, I'm going to put 2 square root of 3 over 6. Now these multiply, right? And so I have 14 square root of 3 over 6. And we should reduce if possible. So 14 over 6 does in fact reduce to 7 over 3 radical 3. And there's my final answer. So what did we do on this problem? Let's review. We followed our rules. It's a 45, 45, 90, so we made the legs match, and we multiplied the leg by square root of 2 to get this side. And we ended up with 7 radical 3 over 3. Now, but multiplying by square root of 2 is a little wild, right? We had to think of that as a fraction. Then we multiplied them together and found we needed to simplify our square root. And after that, we still needed to simplify and reduce. So there was quite a bit going on there. Let's go ahead and see how you guys do with a little bit more of a tricky square root type of situation. Go ahead and try number 8 and see how you guys do with that. When you unpause the video, I'll go through it with you. All right. So I don't know. Well, we have a 45, 45, 90 right triangle, and they've given me the hypotenuse. And to get from your hypotenuse to a leg, you need to divide by the square root of 2. So I'm going to take 5 square root of 3, and I'm going to divide it by the square root of 2. Now, I don't like having square roots on the bottom, so I'm going to multiply the top and the bottom by the square root of 2, which gives me 5 square root of 6 over 2. And this square root does not simplify, so I'm done. Each of those legs will be 5 square root of 6 over 2, and they match because that's how it is with 45, 45, 90. So your answers for the legs are 5 square root of 6 over 2. So sometimes the leg work that you have to go through to work with the radicals can be a little bit more strenuous. But there it is. So that's 45, 45, 90 right triangles. But let's go ahead and take a look at our second type of special right triangle. And that would be the 30, 60, 90 right triangle. On those, you have one 90-degree angle, you have one 30-degree angle, and one 60-degree angle. Now, the side that's across from the 60-degree angle is what I'll label as L for long leg. The side across from the 30 is what I'll call S for short leg. And then the hypotenuse is H, of course. So that's our long leg, our short leg, and our hypotenuse. Now, I guess those labels, though, I'm not going to use those, but I will refer to them as that. So maybe I'll just write it out down here instead in words. My bad. Sorry about that. I'm just going to put short, I'm going to put long, and then I'm going to put hypotenuse. Because you do have those 3 types of legs. Now, here's how 30, 60, 90s work. The short leg, let's call that X. Okay, that's going to be our starting point. Now, whatever the short leg is, the hypotenuse will always be twice that much. So 2 times X. So if you ever have your short leg, you can find your hypotenuse pretty quickly simply by multiplying it by 2. Not square root of 2. That was the 45, 45, 90, right? I get a lot of students that mix that up here. 45, 45, 90s are the ones that have a square root of 2. But for these guys, it's not square root of 2, it's just 2. So in other words, you just literally double it. So whatever the short leg is, multiply that by 2 and you get the hypotenuse. Okay. Now, if you ever want to work backwards, though, what do you think you would do? What if you had the hypotenuse, you need to find the short leg? What do you think you would do? You do the opposite. You would divide by 2. Okay. So if you're ever working backwards, you divide. So if you're going from short to hypotenuse, you multiply by 2. And if you ever go from hypotenuse to short leg, you divide by 2. All right. Now, what about the long leg, though? Well, the long leg can be found by taking your short leg and multiplying it by the square root of 3. Okay. And so we'll put multiply square root of 3. And not surprisingly, then, if you ever wanted to work backwards, what would you do? You would divide by the square root of 3. Now, you might wonder, where do all these numbers come from? How do people know this? Well, once again, it comes from the Pythagorean Theorem. I'm not going to go through it at this time, but it does come from Pythagorean's Theorem. So, as you guys can see, the important side here to have is the short leg. Your short leg, if you ever have that, you just double it to find your hypotenuse, and you multiply it by the square root of 3 to find your long leg. But you may have to work backwards sometimes. So if you have your hypotenuse, you'll start by dividing that by 2 to get your short leg. Or if you start with your long leg, you're going to start by dividing that by the square root of 3 to get to your short leg. Okay, so let's go ahead and take a look at some examples. So what kind of a triangle is this? Well, it's not a 45, 45, 90 anymore, right? This is a 30, 60, 90. Once again, you may be saying, Mr. Bailey, that's only a 60 and a 90. I don't see a 30. Well, the angles in a triangle have to add up to 180. So if this is 90 and this is 60, this would have to be 30 down here in order for the triangle to exist. So they only need to give you a 60 or a 30. That's enough to tell you that you're dealing with a 30, 60, 90 right triangle. So anyway, back to the beginning. What kind of triangle is this? It is a 30, 60, 90. What side did they give me? They gave me a short leg. That's the nicest one to have because that's kind of like the starting point. So if whatever the short leg is, I can get to the hypotenuse if I just multiply it by 2. So what is 4 times 2? Well, that would be 8. So if this is 4, then the hypotenuse is 8. What about the long leg? Well, I can get to the long leg if I just multiply my short leg by the square root of 3. So if I take 4 and I multiply it by the square root of 3, I get 4 square root 3. And that's that. So just double the short leg and multiply the short leg by square root of 3, and you've got the other two sides of that right triangle. Let's go ahead and have you guys try one like that real quick. See if I can find a good one here. Here's one. So go ahead and pause the video here, give that one a try, and see how you do. All right, there you go. So short leg is given on a 30, 60, 90 right triangle. So if I multiply that by 2, I get 18. And if I multiply it by the square root of 3, I get the long leg, which is 9 radical 3. All right, let's go back and take a look at another example. Number 10. All right, on this one, once again, what kind of a triangle are we dealing with? We're dealing with a 30, 60, 90. What side did they give us, though, this time? What side is that? Is that the long leg, the short leg, or the hypotenuse? Well, that's the hypotenuse. And when they give you the hypotenuse, you're going to jump to the short leg by doing what? Dividing by 2. So if I take 10 and I divide that by 2, what do I get? Well, you guys know that's 5, right? So I'm going to put a 5 right there. Now the last thing I need to do is I need to find my long leg. Well, I can get from my short leg to my long leg if I do what? If I multiply it by the square root of 3. And so my answer will be 5 square root of 3. Now just so you guys know, you don't have to write down these arrows and these words here. I'm just doing that for teaching purposes, but it might be nice to have in your notes. But when it comes to classwork, I don't care if you write these down or not. But just so you guys know, you don't have to write those. You really just need the answers. So let's go ahead and see if we can find one like that for y'all to try out there. Here's a good one. Go ahead and pause the video and give it a try. When you unpause it, you will see the solutions. Right, so for this one, once again, we're starting with the hypotenuse on a 30, 60, 90. So if we cut that in half, we get the short leg, which is 6. And if we multiply the short leg by the square root of 3, we end up with the long leg. So x is 6 times the square root of 3. All right, let's go ahead and take a look at yet another problem, number 11. So what kind of a triangle is this? 30, 60, 90. What side did they give us? They gave us the long leg. So when you have the long leg, you can find the short leg by doing what? Dividing by the square root of 3. So if I take my long leg and I divide it by the square root of 3, that'll give me my short leg. These cancel out. I'm left with 2. So the short leg must be 2. And if the short leg is 2, what does that mean the hypotenuse would be? 4. So x equals 4 and y equals 2. All right. So there you guys have it. Let's try. Let you practice one kind of similar to that. I want you guys to try number 12 here. Pause the video. When you unpause it, I will show you my solution. So this is the long leg. If I divide that by the square root of 3, I get the short leg, which is 8. And if I double the short leg, I get the hypotenuse, which would be therefore 16. So that's number 12. Let's see if we can find another one to play around with here. Let's take a look at number 13 here. What kind of a triangle is that? Well, it's a 30, 60, 90. What side did they give me? Long, short, or hypotenuse? Well, it looks like they gave me the long leg. How do you get from your long leg to the short leg? Well, you're supposed to divide by the square root of 3. But 3 over the square root of 3, nothing cancels this time. So that's technically the answer, but as you guys may recall, we don't like having square roots on the bottom. So I'm going to multiply the top and the bottom by the square root of 3, which gives me 3 square root 3 over 3. And therefore these 3's now cancel, and I'm just left with the square root of 3. So by dividing 3 by the square root of 3, I end up with the square root of 3. And as you guys know, that to get from your short leg to your hypotenuse, you multiply by 2, right? So if I multiply this by 2, you don't get the square root of 6. I want you to understand that, because that would be if you multiplied by the square root of 2. But if I just multiply this by 2, it just means put a 2 in the front of it. So it's 2 square root of 3. So m is equal to 2 square root of 3, and n is equal to the square root of 3. So let's review, how did we do that? We have a 30, 60, 90 right triangle. They gave us the long leg. To get from the long leg to the short leg, you have to divide by the square root of 3, which I did here. That required me to rationalize and simplify till I got this for my short leg, and doubling that to get my hypotenuse, right? So let's go ahead and see if you guys can try one of those. See if I've got a good example to match any of those. There's one. So go ahead and give number 18 a try. Pause the video here. When you unpause it, you will see the solutions. Right. Long leg on a 30, 60, 90. We can divide that by the square root of 3, which when you rationalize it, gives me 2 radical 3 over 3. So that would be my short leg, 2 square root of 3 over 3. To find your hypotenuse, you're going to double it. Now, you might have gotten a little confused here. How do you multiply that by 2? Some of you guys probably multiplied the top, some of you probably multiplied the bottom, some of you probably multiplied both. But how do you do it? If I'm multiplying this by 2, you're multiplying that by 2 over 1. And so you only multiply the tops together. So it's 2 times 2, which is 4 square root of 3 over 3. So the hypotenuse would be 4 square root of 3 over 3. All right. Go ahead and take a look and see if there's any other we could play around with. So sometimes you'll get really ugly looking ones like this, so I thought I would do this, a type like this for you. So let's go ahead and take a look at number 14. So what kind of a triangle is this? Well, once again, it's a 30, 60, 90. What side did they give? Long leg, short leg, or hypotenuse? Well, that's a hypotenuse. All right, so what do we do with a hypotenuse? Well, if I know my hypotenuse, I can get to my short leg if I do what? Divide by 2. All right, so that's interesting. How in the heck do you divide this by 2? Right? Well, you're going to do same, change, flip. That 2 turned out really weird. Number 2. And so basically when you're dividing by 2, what you're going to end up doing is just multiplying the bottom by 2, as you can see. So we end up with 10 radical 3 over 6, and that does reduce, by the way, to 5 radical 3 over 3. So since my hypotenuse is 10 radical 3 over 3, if I divide that by 2, I get my short leg, which apparently is 5 radical 3 over 3. How do I get to my long leg? We get there by multiplying by the square root of 3. So I'm going to multiply my short leg by the square root of 3. So that's more fun math that we get to do there. My short leg is 5 square root of 3 over 3, and I want to multiply that by the square root of 3. How do I do that? Well, think of it as over 1. What's the square root of 3 times the square root of 3? Well, it's just going to be 3. If you want to go the long way, the square root of 3 times the square root of 3 is square root of 9, which is 3. So we end up with 5 times 3 over 3. And the 3's cancel, and we're left with 5. So my long leg in that case would be 5. And there's our final answer. So we have a really crazy looking hypotenuse here. We divided it by 2 using this process to get our short leg, which is 5 radical 3 over 3. And then we could find our long leg by multiplying that short leg by the square root of 3, which I've shown my work here, and that came out to be 5. All right, let's go ahead and throw one with some crazy square roots at you guys and see how you do with it. And we'll go from there. So go ahead and pause the video here, give number 17 a try, and we'll see how yours turns out. And pause the video, we'll do it. All right, so for the beginning here, to get from the hypotenuse to the short leg, we would divide by 2. So if you divided that by 2, you should have ended up with this. All you'd end up doing is dividing the 6 by 2, and you get 3. Now, to get from your short leg to your long leg, you multiply by the square root of 3. So it's 3 square root of 2 times the square root of 3 is really just going to be 3 square root of 6. There's not much more you can do with that after you multiply the square root of 2 and 3 together. That's it. Okay, so here's a little bit easier than the one I did, but there you go. All right, and I think we've pretty much covered all of our bases there. We've gone through them all. So hopefully that was helpful, and we'll see you guys in class for some more practice. Till then.